Everybody, welcome to session 5 in the educational series for the Electric Education Center. And this session is on electric services. The National Electrical Code book reference is Article 230. Since aluminum service cable is the type used most often, I want to start with addressing terminations of this aluminum cable. Should we coat the exposed aluminum at the terminals inside the meter pan and inside the main circuit breaker panel? Should we use aluminum juice like Ideal's No-Lox or Gardner Bender's coverage or Scotch coat? I say definitely yes. Some new argument going around concerning the aluminum today being made with better alloys and doesn't need a coating. The answer to all this, of course, is to pay attention to the manufacturer's instructions as NEC section 110.3b tells us to do. The one thing that makes sense to me is what I learned from an experienced millwright, a mechanic on my first job out of college working for Westinghouse. This mechanic told me something that has stuck with me my whole career, and that was never put together a dry connection. Lugs, bolts, mating surfaces, it didn't matter. Second lesson I could pass on is that after inspecting over 1,000 electric services for reintroduction of power for JCP&L in New Jersey, after Hurricane Sandy, the meter sockets that had been covered up and greased up like a greased pig were clean and operable underneath all the crud. Any terminals and lugs not coated correctly or not coated at all were absolute trash. They were rusted and corroded into a solid chunk of metal that could not be tightened or loosened. So it was those meters that were tagged for replacement. Third experience I have to share is this. In a 10-home development I'm very familiar with, after 35 years, the terminations made by the utility on the line side of the underground service meter pans were corroded and loose. The load side, which was landed by the electrical contractor of record, were still tight, greased, and in good shape. So there's another experience after 35 years. The fourth point I want to make is that the conductor termination screws and lugs must be torqued in the first place per the manufacturer's instructions. You don't do it by feel. You do it by using a torquing tool, whether it's a torque wrench or a torquing screwdriver. Any professional worth his salt will use the correct tool to torque his connections. Let's talk a little bit about the main disconnect type and location. The rule in NEC Article 230, and specifically Section 230.70A1, that's 230.70A1, states that the service disconnect shall be installed at a readily accessible location, either inside or outside of the building or nearest the point of entrance. Note that there are no magical foot measurement limits like 5 feet, 6 feet, or 10 feet. The example I like to use is this. When the service cable enters the basement, for example, and it comes in directly over a heating oil tank, you're not going to install a main panel there. You may have to move over a couple of feet to get to a clear spot, so bottom line is the inspector is going to have to be understanding of that. Now, if the homeowner wants you to put the main panel installed 20 feet across the basement on the opposite wall, well, that's going too far with unfused conductors. One resolution for that problem is to install a fuse disconnect on the exterior of the building and then install SER cable from the disconnect to the panel location, and that panel will now be wired up as a sub-panel. And that means the grounds and neutrals are going to be separated. The neutral bar will be floating, and the ground bar will be bonded to the panel enclosure. There's a new NEC 2020 service disconnect rule, and it requires an emergency disconnect on the exterior of all 1 and 2 family dwelling units per section 230.85. 230.85 gives you 3 ways to handle this situation. One way is to put the main disconnect outside and mark it as emergency disconnect and service disconnect and be done with it. A second way is to put in a disconnect with the label on it that says emergency disconnect and not service disconnect on the outside of the building. And what that means is you're not going to be running any grounding or bonding green insulated conductors to that enclosure. And then you put the main disconnect on the inside of the building. And when the main disconnect is in the inside of the building, then you're grounding to the ground rod, and you're grounding to the metallic water pipe, for example, will start from that location. The third way is to install some type of a meter and disconnect that are contained in one enclosure. Now, having said that, and before installing service equipment, and until you know how to determine where service equipment should be located, you should always meet the requirements of the electric utility in your area. A service and meter form, commonly called an S&M form, should be filed with the utility. They may have a say on acceptable equipment models, what voltages are available in the area, where the grounding electrode connection can or cannot come from, where on the building or property the service could be installed. Back in the 90s in Levittown, PA, there was a rule put out by the utility that said that any service equipment installed or upgraded had to be relocated to the front of the fence, outside in the front yard area, outside the fenced in area. They were tired of meeting up with dogs and dealing with locked gates and stuff like that. So that was just a local rule for Levittown, PA. So there may be special rules in your area. How to meter solar PV and wind systems is definitely something that's controlled by the utility. How to connect optional standby generators, the Kohler or the Generac you put in the backyards. How to export and import power for electric vehicles is now addressed in the National Electrical Code, Article 625. Now it's time for the middle 8 minutes, and the question is, let's say a dwelling unit has an ITE Bulldog Pushmatic style panel. Can a faceless AFCI/GFCI dual purpose device be installed near the panel and then run a circuit to one new receptacle location? It seems to me like you could, but the code book says that you have to have a metallic raceway, don't forget, to the first receptacle. So would a faceless count as that? Possibly. You're going to have to check that with your inspector. And it seems like LeGrand, Patterson Seymour has such a faceless device, dual purpose device. So as I said, the rules for service installation are contained in Article 230. And if you turn your National Electrical Code book to the first page of that article, you'll see a handy diagram of an electric service. Try it out. Just pause this video and turn to the first page of Article 230. So let's say you have a question about service entrance conductors. You come down the left-hand side of the diagram, and when you see service entrance conductors, you follow across the diagram to the right, and you'll see Roman numeral Part 4. You can also come down the list at the top of the diagram and end up at the same Roman numeral Part 4. Two tricks the people in my exam prep class use are to, first of all, write in the page numbers from your code book alongside to the right of the Roman numerals. And secondly, they use a highlighter to light up the parts once they locate them, because it's hard to pick them out when you're in a hurry because they're all black and white. So they would highlight the individual parts, both in Article 230 and Article 430, which is motors. All right, service terms. An overhead service is called a service drop. An underground service is called a service lateral. The cap at the top of the outside cable is called a weatherhead. For a new home in the suburbs, the service lateral will come up into an underground style meter pan installed on the outside of the home. If there's a service drop, it will drop down into the overhead style meter socket. Older homes in Boston, New York, Philly, Baltimore, Atlanta, San Francisco, etc., have service laterals that enter through what is called an end box in the basement. Check with the utility, but most likely the utility wants a metallic conduit from the end box to the main disconnect. They may not want greenfield either. They would most likely require rigid, IMC, or EMT conduit for that run. So again, check with your utility. Arrange to drain in the NEC section 230.53, 230.53. Any raceways enclosing the service entrance conductors must be arranged to drain. And that means exactly that. The raceways and conduits installed should not hold water. You have to use drain holes, conduit drain fittings, or whatever it takes to drain any water that could enter that raceway and conduit system. After Hurricane Sandy in New Jersey, there was lots of PVC conduit runs, for example, that dropped down out of meter sockets, out of overhead meter sockets, and then turned and ran into the main disconnect location and then turned back up and into it. Well, when the floodwaters rose, the conduit was filled up and there was no way for the water to drain out. There was nasty water and contaminants in the pipe. And then on top of that, the water is still there after all these years. It's freezing and thawing and shortening the life of the insulation. Also, you know, these electric services, speaking of the shore areas of the Atlantic Ocean, Pacific Ocean, and even the Gulf of Mexico can take an awful beating from the sun and the rain and the salt water and the wind-blown sand. So, for example, there's one area of New Jersey that will only allow the old style gooseneck at the top of a service drop cable. They won't allow weatherheads to be installed because they corrode, they get chewed up, and then before long, you don't have any kind of protection. And then you have water that comes down into the inside of the house because the weatherhead is gone, and the rain can channel right down the service cable and then into places that it shouldn't go. Let's get back to preventing water from entering the equipment. You may have seen, or you will see, circuit breaker panels that have only one side of the circuit breakers row being wet and the terminals are all rusted. And you say, where's that water coming from? So you check the weatherhead up the top of the service cable. There's no problem there. You check the meter socket and there's no problem there. There's two possibilities left. One is rainwater and the other is condensation. Either way, the leak damage could have been prevented. Never take a service cable directly diagonal into a panel. And the reason you do that is because you bought too short of a piece of service cable in the first place. If you need 20 feet by 30, if you need 30 feet by 40, because then you find out, oh man, I forgot I need 3 feet at the weatherhead. I need a little bit extra to make these loops at the panel. Yeah. So think ahead. If you need 30 by 40. Also, after entering the panel, you could form some type of a drip loop. I'm going to show you a little bit on this panel behind me. And you got to do what you got to do to make sure the system drains away from the energized parts. So let's take a look at a 100 amp panel and see what we could do. Okay, in this panel, we have, I'll use my ground rod as a handy pointer. We have a couple issues going on here. First of all, when you come in with your service conductors, all right, you can see that I have them aimed upwards so that if there's any condensation that comes into this, by way of this cable, okay, it's not going to make it over to the terminals on the main breaker. It's going to drip down here in the gutter space. And then there's holes in the bottom of this panel. There's spaces at the two front corners where water can make its way out. The second thing here is the bonding screw. These are Siemens panels and they come with the bonding screw already installed. And this is the only screw in the whole National Electrical Code book that has to be green. The reason it's green is so the inspector can see it. Now, you might say, oh, they don't come in the bottom of the panel anymore. Well, some of them do, but Siemens does not. They come already in the hole, but they're not driven home. If you have to, if this is a service panel, a main disconnect panel, you have to drive that screw home. And I mean drive it. Okay, it's not easy to drive that screw in. The next thing we have here is the neutral bars, 2 neutral bars and 2 ground bars here. This copper bar that jumps across from neutral bar to neutral bar is not meant to be removed. I had a contractor, I went to do an inspection one time, and this bar here was cut out. He cut it at both ends. He says, Rich, he said, I hope you don't mind if I had to cut the bar and leave it there. He said, I couldn't undo the screw. Well, don't you think there's a reason you couldn't undo the screw? This bar is not made to be removed. Now, other panels do have a jumper bar across the bottom or one that goes in the back. I understand that. And they're made to be removed. But this guy is not meant to be removed. So don't remove it. They give you plenty of ground bar connections over there and plenty of neutral connections here. There's no reason to take this bar out. The other thing here is the new finger safe protection that the manufacturers are putting in. And that's here at the main lugs, okay? And you can see that they have these plastic pieces that will protect you from accidentally touching the lug. Next thing. Somebody asked last week about a factory handle tie. This is a factory handle tie, one that comes with the circuit breaker. And it's not something that you can home make. All right, factory handle tie. I think that's it. Now, the torquing of these main lugs is different from the torquing for these neutral bar screws, is different from the ground bar screws, okay? And it's different from the circuit breaker requirement, okay? It'll tell you right on the circuit breaker, this has to be tightened up to 35/25. This breaker is 25 inch-pounds. 25 inch-pounds or 25 pound-inches, doesn't matter, same thing. But it'll tell you there, and that's how much you tighten up this screw. That is the perfect torquing that the manufacturer wants to perfectly compress the copper conductor or aluminum conductor and follow their instruction. This is a torquing screwdriver here. This goes from 0 to 40 inch-pounds. Okay, so, and another tip, because I had a muscle head in one of my classes that wrecked my torquing screwdriver. The torquing screwdrivers are only for tightening. They're not for loosening. Okay, and then the aluminum connections, don't forget, no locks on the two terminals here and no locks here on the neutral bar. And I think that pretty much covers it. If you have questions, go ahead and send them in. The other thing is, I want to mention this. If this is your circuit breaker panel, again, don't come directly, diagonally straight down into a panel like this. Okay, all you're doing is giving a nice runway for water to enter the panel. All right, make some type of a bend, okay, like that, which will give a place for any condensation or outside water to drip off out here, outside of the panel. Okay, so that's a little bit about the electric service panel itself. Let's talk a little bit about grounding and bonding this service equipment. Why are we grounding? First of all, grounding means just that, connecting to Mother Earth. We ground mainly to channel lightning and surges to the ground, to dirt. Why are we bonding? Mainly to provide a nice low resistance path for fault current back to the source it came from, and that is the electric utility. It may be a transformer on a pole, or it may be a pad mount transformer in the yard. You see, there's two kinds of electricity, and I don't mean AC, DC. The two kinds are the kind that God makes, and that's called lightning. And lightning is truly trying to get back to Mother Earth, so we have to provide a path for it. The other kind of electricity is the kind that man makes. And that's the electricity that comes from the utility transformer. And after it does its work, it's always trying to get back to the utility transformer it came from. Knowing these two facts will explain a lot of questions in your mind, and it's going to help you with your troubleshooting. So how do we ground a service? See Article 250, which is extensive, and we'll be covering grounding and bonding separate in other series issues of these sessions. But particularly 250.66 will explain that the connection to a ground rod never has to be larger than a 6-gauge copper. That's because the ground rod is meant to guide the lightning surge to Mother Earth, and the lightning event lasts only microseconds. But for that short period of time, the 6-gauge is all you need to handle the power and channel it to ground, to Mother Earth. Now, I know what you're saying. There are architects, engineers on the drawings. They want 2-aught and 4-aught and 500 kc mil conductors connected to ground rods and things like that. I understand that, but they're trying to serve a different purpose. And the main thing for you is follow the engineered drawings that you bid to. So how do we bond a service? Well, it all starts with the utility neutral wire. That's the wire that gets connected to the center terminal of the meter socket, and that's already bonded to the meter panel. The service cable that's installed from the meter socket to the circuit breaker panel bonds both of those metal cabinets by using that bare concentric neutral. The neutral bar is bonded by the green screw or a copper strap to the circuit breaker panel. So to follow the path for fault current from any branch circuit in the house, the fault current would return to the circuit breaker panel by way of the equipment grounding conductor. Then it would go into the neutral bar, and it's got a decision to make. Do I go down through the ground and start digging to get myself back to the transformer I came from, or do I take the easy way by just running along this concentric neutral? The answer is easy. If it were you trying to get home, which way would you go? So the fault current needs to have a nice permanent low impedance path. That means low resistance, back to the source it came from. Practice it yourself. Just stand back and start at the toaster in your kitchen and visualize the path for fault current if a hot conductor should touch that the metal of the toaster. And follow that path for fault current back. And if you could trace that complete circuit back to the utility transformer through the panel and all that, you did your job. So there's a little bit about electric service, a little bit about grounding and bonding. We'll see you all next time. Van Wert out.